Miss Brophy. Okay, so basically we did the entire experiment and wrote down all the data, and this is us showing you what we did. Okay, so in each cup we have 300 grams of water, which is 300 milliliters. And then we put 0.0105 moles of baking soda in this cup, and in this cup we put 0.0025 moles of sugar. And in this cup we put 0.01515 moles of NaCl, which is salt. And then let me measure the temperature of the freezer. It is about 8 degrees Fahrenheit, which is negative 13 degrees Celsius. And according to Newton's law of cooling, it should take about 50 minutes for these to freeze. So let's put them in the freezer. Because of the colligative properties, it says that due to ionization and dissociation, adding these different things should suppress the freezing point and make the boiling point rise. The equation of K, the constant, times the molal times the amount of ions in the solvent gets us this equation, which ends up with our freezing point for salt water should be negative 0.1879685. Now it is time to check the temperatures of the solutions because they begin to crystallize. Baking soda is 26.8 degrees Fahrenheit, which is negative 2.8722 degrees Celsius. Sugar is 30.9 degrees Fahrenheit, which goes to negative 0.5944 degrees Celsius. And salt is 23.2 degrees Fahrenheit, which goes to negative 4.8722 degrees Celsius. Now it's time for our second data point. Okay, so temperature of baking soda appears to be negative 2.8166 degrees Celsius. The point of sugar seems to be negative 1.2611 degrees Celsius. And salt is negative 4.8166 degrees Celsius. This is our third checkpoint of the freezing points. Baking soda is negative 2.8772 degrees Celsius. Sugar is negative 1.0388 degrees Celsius, and salt is negative 4.5388 degrees Celsius. This is the equation for boiling point. You take the constant of water, which is 0.52, times the molal of the solution, times the number of ions that will be created when the solution is dissolved, which is 2, because Na goes to oxygen and the Cl goes to the positive portion of the two hydrogens. So when you do this equation, you end up with a boiling point of 100.5255 degrees Celsius. Adding ions to water causes the solution to bond together more strongly, which requires more heat to boil off the molecules. This can be seen in an increase in the boiling point.